Hello students. In the first module of our subject microcontroller and embedded system, we have gone through the architecture of the ARM processor. Now in this video we will discuss about the ARM instruction set. So the ARM is a 32-bit processor. It provides many instructions for the user to write the assembly language program for ARM processor. First type of instructions which are provided by the ARM processors are data processing instructions. So what is this data processing instruction? So data processing instruction, as the name indicates, these instructions are used to process the data. Okay, so first type of data processing instructions are move instructions. So first type of data processing instructions are move instructions. So first see how many types of move instructions are there. There are two types of move instructions. The first one is move. The first type of instruction is move instruction, which is used to move a 32-bit value into a destination register. See the syntax once. So here we have the source operand. This source n represents the source operand. Source operand may be the immediate operand or it may be a register, some general purpose registers like R1, R2, R3, so like that. So this move instruction, it moves a 32-bit value of the source operand into the destination operand. That is first type of move instruction. See the second type of move instruction, move negate. So N stands for move negate. So it is used to move the ones complement of the 32-bit operand into the destination register. So ones complement of the 32-bit operand into the destination register. Now consider the syntax of move instruction. Consider the syntax of move instruction. So in the first column we have to write the instruction. So first column we have to write the instruction. So this instruction can be move instruction or move negate instruction according to the requirement of the program. And second column we have to write the condition. So condition is enclosed inside the parenthesis. That means the writing the condition for move instruction is optional. And third column we have to write the suffix s. So and the fourth column we write the destination register, and in the fifth column we write the source operand. So as I told earlier, this source operand, it can be an immediate operand or it can be a value which is stored in the 32-bit register. Okay. So now consider the condition. What is this condition? So in the first module we have gone through this topic called conditional execution. That means in case of ARM processor, 80% of the instructions are conditional execution instructions. That means based on this condition, the processor will decide whether to execute the instruction or not to execute the instruction. That means, so say for example, we write the instruction like this: move not equal R1, R2. So if R2 is equal to R1, so once again I will write the instruction here. So the instruction is like this. So we write the move instruction. Condition written by the user is not equal. These two registers are not equal. So this is the comma. So R1 register is the destination operand and R2 register is the source operand. Move is a instruction. Not equal is a condition. So this instruction is executed only when R1 register is not equal to R2. So that is the meaning of condition. But it is not necessary that we have to write this condition always. So condition is optional depending upon the requirement of the program. So here that is the condition. So we have gone through this condition in the previous module itself. So many conditional mnemonic codes are there. So just once go through the module 1 for this condition. Next, suffix s. So we have used in our lab program, that is ascending the array in the arranging the array in the ascending order, arranging the array in the descending order. In this program we have used this suffix s. So that means we use the suffix s like this: move s. Sometimes we want that the processor has to affect the flags which are stored in the flag register. So in that case we use the suffix s. So otherwise the instruction is just move instruction or move negate instruction. Okay, so suffix s, when we have to use the suffix s, if we want the processor that after execution of the move instruction the content of the flag register should be changed. So in that case we use the suffix s. And other thing is the destination register and the source register or the source operand. So this is about the move instruction. Now consider the example for move instruction. So here we have written the move instruction. So this is the source register and this is the destination register, that is the R7. After execution of the move instruction, the R5 register content is copied to R7. So we have used this move instruction in our lab programs and also in case of our example programs many times. Okay, so now consider so one more example for move instruction. One more example for move instruction using the logical left shift operation. Okay, so in case of data processing instructions like move instructions, barrel shifter is used. So we have gone through this barrel shifter topic in case of first module. It is a hardware component. It will pre-process the data. Sometimes if we want to perform logical left shift operation or right shift operation, logical right rotate or left rotate operation on the source operand, so in that case barrel shifter is used. With the help of barrel shifter, this logical left shift operation is performed on the source operand, where source operand is R5. So how many times we want to perform the left shift operation? So according to this data it is 2 times. So before copying the content of R5 register into R7, first the R5 register content is logically left shifted 2 times. Then the result is copied to the R7. So this is one more example for move instruction using the logical left shift. It is not always logical left shift. Any logical operation, left shift, right shift, rotate, right rotate, left rotate. So like that. See the how. So here the R5 is logically left shifted 2 times and the result is stored in the R7 register. So R7 is 20. So just try to do this, how we get the 20 after performing the logical left shift operation on the value 5. Okay, now consider the operation of the barrel shifter. Okay, so here the first RM is the source register. We want to pre-process the source register or the source operand. So that is why this source operand is provided as input to the barrel shifter. This barrel shifter, it performs logical left shift. So logical left shift, logical right shift, arithmetic shift right, arithmetic shift left. So all these operations, or it may be rotation operation, so all these operations as indicated by the instruction is performed by the barrel shifter. Okay, so finally after performing pre-processing the source register, the result is generated from the barrel shifter. This result is given as input to the arithmetic logic unit. Arithmetic logic unit, it copies the source operand, pre-processed source operand into the destination register. So this is the operation of the barrel shifter. Okay, so now consider, see this one, these are the different operations. So these are the different operations which are provided by the barrel shifter. So see here, this is the source register. So we have to perform the logical left shift operation. How many times we want to perform? So that is indicated by the immediate value. Okay. Similarly, here instead of writing the immediate value, we can write the register also. So sometimes, if we want to perform the logical left shift two times, then we can store that value 2 in the source register, RS register. So like that. Similarly, here we have the logical right shift, arithmetic right shift, rotation operation. So for this arithmetic right shift, we can provide the immediate value to indicate how many times we want to perform right shift, or that number, how many times we want to perform right shift operation. That number can be stored in the register RS. RS is any general purpose register. Similarly, we can perform the right rotation operation also. So these are all the uh, operations which are provided by the barrel shifter in order to pre-process the source operand before they are moving to the destination operand.